Hey everyone, today we're going to do a video on exploring why is one of our log rules stating that the log of a to the power of x equivalent to the exponent x times the log of only a. So we're going to start with some examples to kind of illuminate what we're talking about, and then we'll move on to some more general kind of explanations, okay? So let's start off with an easy example, the log base 2 of 4. Now, if you watched our last video, we know that this is analogous to asking 2 to the power of what is equal to 4, because that's what a logarithm does. It asks the question, 2 must be raised to the power of what? 2 must be raised to what power to become 4? And the answer to that question is that 2 must be raised to the power of 2 to equal to 4, because we know that 2 squared is equal to 4. And so we have our solution that x is equal to 2, and the solution to this equation is exactly the answer to this logarithm. The log base 2 of 4 asks 2 must be raised to what power to become the 4? And so our answer is 2. Okay? Much like it is here. Okay? Now, let's write our next example in a slightly different way. Okay? Well, let's start off by actually evaluating it as it is, and then we'll write it in a different way to illuminate the concept that we're looking at. So the log base 2 of 64 asks the question once again, 2 must be raised to what power to become 64? And so a different way to ask the same question that might help you think of the answer is 2 raised to what power is equal to 64? Now, this is showing us that a logarithm is essentially disguised as an exponential function that we have to solve. 2 to the power of what is equal to 64? You might be able to just think of the answer, right? You might be familiar with these enough to know that the solution to this equation is that x is equal to 6. And we can verify this because 2 to the power of 6 is in fact equal to 64. And so 2 must be raised to the power of 6 to become 64. And so the answer to our logarithm is 6, okay? Now, another way to think of this is, since 64 is equal to 2 to the power of 6, then we can write this as the log base 2 of 64 is the same thing as 2 to the power of 6, and so we can write it as 2 to the power of 6, right? Log base 2 of 64, same thing as log base 2 of 2 to the power of 6, because we have that established here. Now, let's see if this supposed law actually holds for this example. So, we know the answer to this is 6 because 2 has to be raised to what power to become 2 to the power of 6? Well, clearly we know the answer to that is 6. Now let's see if the right side of this equation holds. So if this is supposed to be equal to, the exponent comes out front, becomes 6 times, and now just the log of the base of the exponent. And so log base 2 of 2. Log base 2 of 2. Is this true? That's what we're investigating, right? And so this is going to be 6 times. Now what is the log base 2 of 2? Well, it's the question, what does 2 have to be raised to the power of to become 2? Well, that's just itself, and so it has to be raised to the power of 1, right? And so the answer to this log, is 1, because 2 raised to the power of 1 becomes 2. And so we have 6 times 1, which is clearly equal to 6. And so we have at least one example where this does work out favorably. We can do the same up here. Since we know that 2 squared is equal to 4, we can use this now found knowledge to investigate this rule again. Let's see if this is the same idea as asking the log base 2 of, instead of 4, we'll write 4 as 2 squared. So the log base 2 of 2 squared. Okay? Let's see if that works out. So if it does, then the exponent should be able to come out front, and so the 2 as the exponent will become the coefficient, and so we'll have 2 times the log base 2 of 2, I know these are all of 2's, bear with me here, and again, the log base 2 of 2, as we've already established, is simply 1, because 2 raised to the power of 1 is equal to 2, right? And so once again, we get 2 times 1, which is equal to 2. Exactly the same result that we found the first way it was written. And so far we have 2 examples where these 2 sides are equivalent. And so let's think more generally about this log rule in terms of the log base b of a to the power of x, okay? Now, let's remind ourselves what an exponent is. A to the power of x, written out more explicitly, is really a multiplied by itself x times, right? X times. That's what a to the power of x means. It's a multiplied by itself x times. And so if we look at this log, what we really have here is we have the log base b of a to the power of x, and if we write it out like this, it might be easier to kind of see this rule popping out. Well, let's write a to the power of x as a times da 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 times a, again, doing so x times, okay? Now, the log base b of a, that's one thing, right? But now we have the log base b of a times a times a times a times a, and so on and so forth. So let's use a variable to kind of make our lives easier. Let's establish that the log base b of a, just by itself, let's say is equal to y, okay? Just to have a variable to help us out. Well, if that is the case, then what we have here is the log base b of a times a times a times a times a. So for b to become just one copy of a, for b to become just a once, it has to be raised to the power of y, right? So that tells us that b to the power of y is equal to a, okay? And so if b is raised to the power of y, then we have one of the a's taken care of, okay? But we have x copies of a. And so if we move forward, we'll have that this is equal to the log base b of a x number of times, right? Because every time we raise b to the power of y, we get 1a. And so every time we raise b to the power of y, we get one of the a's. And so we have to raise it to the power of y x times, right? We have to raise it to the power of y here. Let me write it. We have to raise it to the power of y an x number of times, right? So now we have x times y, because every time we raise it to the power of y, we get one of the a's, and so when we raise b to the power of y one time, we'll get the first a. When we raise b to the power of y 2 times, we'll get the second a. When we raise b to the power of y 3 times, we'll get the third copy of a, so on and so forth, up until when you raise b to the power of y x times, we'll get the xth copy of a. And so we have to raise it to the power of y, because again, that's what the log is asking. It's asking us, what do we have to raise b to the power of to make it become a to the power of x? Well, we have to raise it to the power of y x times. And so x times y. And we established, over here on the right, that y is the log base a of b. And so if we substitute that back in, then what we really have is x times log base a of b, which is exactly what we were looking for from the get-go. And so we have the log base b of a to the x, that's this. We can put a base, as long as we put the same base, we're good to go, is equal to x times the log base a of b, okay? I hope this kind of illuminates some of the concepts behind logarithms and the connections that could be made in the hopes of understanding why this rule applies. And this is a rule that we use all the time as we get into higher levels of mathematics in high school. And so I hope this kind of helps you understand how the rule applies and why it's so useful. So if you guys have any comments, suggestions, requests for future videos, please let me know, and thanks for watching.